Darren has $123,456 in his savings account. Tabo has $156 in his savings account. I feel you, Tabo. Determine the order of magnitude of Darren's account and Tabo's account. How many orders of magnitude as great is Darren's account as Tabo's account? So determining order of magnitude involves rounding. So Darren's account has got $123,456. And so we're going to round that to the nearest, let's say 100,000. This is about $100,000. And the reason we're rounding it like that is so we can put it into some form of scientific notation. This is 10 to the third power. If we wanted to, we could say that this is 1.2345 times 10 to the 1, 2, 3, 4, 5th power. We'll come back to that in a second. Table, on the other hand, my spirit animal, only has $156 in his account. This is about $100, which is 10 squared. I don't know why I wrote 3 here when I meant 5. Derp. It's a 1 with 5 zeros, Taylor, not 1 with 3. So 100,000 is about 10 to the 5th, and $100 is about 10 to the 2nd, which if we wrote this in scientific notation, it's 1.56 times 10 squared. Again, the scientific notation is an unnecessary step. To find order of magnitude, we're really just interested in the 10 to a power part. So that's the part we care about. But if you're uncomfortable with the rounding and you're like, I don't want to round, I want an exact answer, turn it into scientific notation, and then we just want the order of magnitude, just the times 10 to whatever power. So this is the order of magnitude. Darren's order of magnitude is 10 to the 5th. Tabo's is 10 to the 2nd. The question is, how many orders of magnitude as great is Darren's account than Tabo's? And that's where our exponent rules come in. Darren's is 10 to the 5th. Tabo's is 10 squared. And so we use our quotient of powers property here to just subtract the exponents. 5 minus 2 is 3. So we would say that Darren's, does he have 2 R's in his name? No, 1 R. Darren's account is about 10 to the 3rd times as great as Tabo's. Darren is living large, and Tabo is a public school teacher. So Darren's account is about 10 to the 3rd times as great as Tabo's. So really just concerned with the 10 to a power thing, which we can find by rounding. If you don't like the rounding thing, just do scientific notation. Let's do one more. A circle has a radius of 210 centimeters. How many orders of magnitude as great is the area of the circle as the circumference of the circle? So 210 centimeters, if I wrote this in scientific notation, it would be 2.1 times 10 to the 2nd power. But rounding, I just rounded this to the nearest power of 10. 210 is closest to 100, which is 10 squared. So rounding, I think, is the faster way to do it. But again, if the rounding thing confuses you, I'm curious about the power there. I'm comparing this to the circumference of the circle, so I need to know what is the circumference of a circle that has a radius of 210. Well, the circumference is found by 2 pi r, which in this case is 2 times, I'll just use 3.14 for pi, 2 times pi times the radius. So 6.28 times 210. Don't know what that is, so let's do 6.28 times 210, 1,318.8. This is closest to 1,000. Which is 10 to the 3rd power. So that's the order of magnitude is 10 to the 3rd. But again, if we want, we can write this in scientific notation. 1.3188 times 10 to the 3rd power. Either way, we just care about the order of magnitude, which is 10 to the third. So the question is, how many orders of magnitude as great is the area of the circle as the circumference of the circle? So we've got the circumference as 10 to the third. Let's find the area now. The area is pi r squared, which is pi times 210 squared. So let's go back to our calculator. We need to do 210 squared times pi, 138,474, which is 1.38474. This is closest to 100,000, which is 10 to the fifth, but I'm just doing it in scientific notation way. This is about 100,000, which is 10 to the fifth. So order of magnitude is 10 to the fifth. And the question was, how many orders of magnitude as great as the area than the circumference? So the area is 10 to the fifth. The circumference is 10 to the third. And my exponent rules say 10 to the fifth divided by 10 to the third is 10 squared. So the area is 10 to the squared times bigger than the circumference. And that's how we do order of magnitude problems.